Welcome back, everybody. Thanks so much for the viewers. How do you find it? Is any comment, please drop any question you have, please drop it at the comment section. Today we go into the data type. We look at the data type, the size of the data type. We also compare them. We now see them, the reason why we need to use them. I will be projecting the first slide we have last week, or we had our previous lectures. Let me show you. We have the lectures there, just briefly. Sorry for the long video of the last time. So we have it, variables. We use is used to represent reserved memory locations. That is to store something. We see in our previous lectures, X is a variable, X1 is a variable, S2 is a variables, Y is a variables. It can also be booleans. We've seen integer, we've seen floats, and we also have void. That does not mean what it should not return anything. So can you see, if you see this slide, once we declare a variable int x, the size of this int by default is 4 bytes, and 1 byte is 8 bits. That is what? How many bits we have there? That's what we have, 32 bits in this. We don't specify the type, but by default it's 32 bits. The integer size, bit size, is 32 bits. And we see our memory as well. Our memory, our RAM is in what? It's in bytes. It's in byte form. Now, let's proceed. We check it as we go on as well. You see, compared to us, we see, let's look at some types. I got this from Programmings online. I think he explained the 2 bits. Both these are both used in C and C++. You can see you have 4 bytes here. Usually what? Usually 4 bytes. Car, 1 byte, that is 8 bits. Float, 4 bytes, same thing. Double is 8 bytes, that is 64 bits. 64 bits. Short int, HD, you can see this type. We can use them as long in any variable. If we are using C, or we want to have a specifier. Specifier, we're going to see this one later on. Maybe you want to display unsigned, you want to display a variable in your C programming language. You can also specify this in your print statement. We have this here. You can see now, the other time I told you, you can go from negative to positive. Understand? You can see, if you see your calculator, we bring your calculator. If you can see now how many bits do we have in 32 bits. That is a what? 4 bytes in 32 bits will be what? That will be 31. 0 to 31. 0 to 31. That's 2 raised to the power 31. 2 raised to the power 31. 2 raised to the power 31. 2 raised to the power n minus 1. That is 2 raised to the power n. That is 32. 2 raised to the power 32 minus 1. To get these values. That is a certain number of storage it can take. It can take this number from value from negative so and so to what? To a positive number so and so. That is the only way we can get our value from. And then we also have in short, you can see 2 bytes here. I got this one from online elsewhere. Online as well. I don't know why I don't even reference it. Online Programmings and Java points. I got it from them. So we also have keywords. In their first lectures, remember, I don't know what keywords are. Keywords, they are the one you cannot use. The compiler recognizes them as part of it, so it uses them for specific purpose, like car. You can't name them as car. You won't use them by car. You have to attach something else with them. For example, see here, S int here. You can rename them to be X int, int S. You can't just use int normally. We have 2 keywords in C. We have more than that in C++. We also have some reserved words. All right, let's go into our code now. We go we open our VS Code, Visual Studio Code. Minimize this, and we open our Visual Studio. It's our previous lectures. Let's create another folder. Let's call it P3. That's what data type. We put it's inside this folder, but we can pull it out. Let's put it out here. Here, move it. Then we close this up like this. Then we create a file inside it. Create a file inside it. Let's just call it data type .cpp. All right, we have a blank new page now. So let's include our star library input output string within C. Remember what you're going to use. You're going to use what? std. You know, C++ is a superset of C. You can also use it here. stdio. Understand? .h. Can also include it here as well. So, and C use a C++. Can still use a C++ library, but we are in C++. Let's change it to C++. Now, then we talk about data type. We talk about hints. Let's verify the size of the hints. Let's try to store. Let's first check int. What is the size of int? There's a function called size of. Cout. Let's include our namespaces using name. Let's go talk about namespace later in the future. Namespace std. I just start using them like that. Cout. Size of. Can you see? Size of. Tell us the size of a variable. How many space does it occupy in the RAM? In our RAM. So you have to be careful as well every time you deal with variables. Some will just use variable int every hour. Anytime you just see you declare them as int, it's not a good idea. It's not a good programming practice. Just declare them. Maybe what you are dealing with doesn't take much space on the memory. You don't need to declare them as memory. Just you are dealing with binary or bit. You don't need to be declaring them as in 32 and 64. No. You can use the normal variable. You can use boolean. You can take two values on and off. Or this. Let's check the size of int. By default, we said that by default is 4 bytes. Let's check if it is 4 bytes truly. Let's check if it is 4 bytes truly. Size of. Okay. All right. So we get here. So let's compile this. Let's move out of this folder. We've not left this folder now. Let's move out of it. Let's change that directory back. Stand. Then we move. We are on Windows. Command a little bit different, but I'm on Linux machine, Fedora precisely. So, and then let's compile this. CD. Let's change the P3. Let's compile this. G++ output. Data type. Let's give it a name. Don't give it a name. Let's just give it main data. Let's call it main data. You can call it anything you want. Let's run it now. You can see it's giving me 4 here. It gave me, that means 4 is by default 4 bytes. That means this is 4 bytes. 4 bytes. By default. But in case you want to deal with integer and still more than 4 bytes, title bit is 4 bytes. For example, you can come here. Let me control space. You can see we have 16 bit. You can see now if you change to 16. Let's change to 16. Let's see what's going to be. That's called 16 bit. So 16. It's 16. Let's go T. All right, now we have it here. Whether you even say there, maybe int 64 T can be what? Maybe of X. Okay. Let's check this now. Let's check either of them. Compile, check. We have 2 bytes. See, this is 2 bytes. Here, let's check for x. You can also put x there. You can put the type there. You can put the name there. Checking the type. So let's see what the type, what carries. Let's see the time. As you have 8 bytes, 8 bits, 8 64 bits. 8 bytes as 8, that's 64 bits. Understand? I think we have in some program like Rust, we have like up to 128, or I think we have yeah, we have 64 bit representation. Now you can also use size t. I think it's also default. You don't know that, just give it the size t of x. Just give size t is what? It's what byte? That is that's 8 bytes by default. I know of yes, that's 8 bytes by default. 8 bytes by default. Let's see if to float to confirm that. Float also is 4 bytes by default. I mean, size t should be, sorry, let me go back. Size t should be 4 bytes. And not compile it. 8 bytes. Apologies. Apology. So we have that's float. Float 16 the same way. Can you see you have float 64 here? Float 64, float this and that. You can see. Float 128. And maybe you want to have here. Let's check. I think. Yeah, 16. Can you see? 16. Oh my God. I have a large storage. So now, since we know what they're capable of, the size of that. Okay, if I now say, if I print the size of this, if I now assign, remember in our slide we said, let's take the size of this and let's assign a value to it, int x. Let's assign more than, because let's come to it. Let me show you again and slide back. Let me show you and slide back. Can you see this slide? I want to show something. I want to store something to offer. I want to show us something. You can also check the rest. You can also show, I want to show us something. For example, int 8 bytes. The value of it. I want to show us the value. Int. Let's try to get, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's assign more than 10 values to it. Let's see to our VS Code. Let's see, maybe we're going to have all the values going to be displayed at the time. Let's go back to our, Visual Studio, and let's assign it to them. Let's assign the 10. That one's 10. Let's assign what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let's assign this to it. So let's just print. Let's print the value of x. See out. Let's compile this. It's a what? I'm seeing error here. Can you see word overflow exception here? It's a word overflow here exception. It changes value from this to this. Understand? We have overflow in conversion from long int, but you can also make it long in case you are not sure of the size you want to store. Just put long at the front of it. Oh, it's going to accept that now. So now you can see with that error, it accepted that. Then you can run it. Can you see now it displays the value without deductions? Sometimes in Java like that, you see some of the value will just be cut off without a warning from the compiler. And so our compiler and the thing has been modified. Just shut them off. You cut them off for maybe the area we don't need, or maybe 10 digits above. You just cut them off. But here we have a warning already telling us that we need to do that. The other time we talk about okay, I don't want us to bother us too much on this again. Thanks very much. Please subscribe for more for more good practical example like this, or more than that. We're going to see, but then we go deep, we know the basis very well. We're going to be working with real life scenario with practical application problems. Have a wonderful day. God bless you.